So any part that we need to design needs to be in 3D space. But how do we translate the 2D screen of our computer to make 3D parts? In Fusion 360 and most of their parametric CAD packages, we're going to do this through a sketch extrude process. So let's say that you wanted to make, I don't know, just a rolling pin for making cookies or something. If you think about the shape, all it is going to be a cylinder. Obviously, you can't just draw a cylinder freehand in space. So you would start by just simply drawing the You would start by simply drawing the. You got any more into there? Are these?
Pump a little hand sanitizer alcohol into them.
Seriously?
No, I don't know.
I don't think that's how it works. You want to run next door and steal a couple?
Sure do, yeah.
Want to run the other way? Grab a couple? All right, pretend there's a very beautiful circle here. So essentially the process is going to be that we're going to draw something in a 2D sketch plane and then extrude it. So to make our rolling pin, we'd start by drawing a circle and extruding it out to the length we want to make the cylinder. For making the handles, we would draw smaller circles and then extrude those out to make the handles. Once we have the base geometry down, we can then go in and clean it up, add any curves, add any like smooth lines to it, add any chamfers, threads, anything else that we'll need. Then you just repeat that a couple hundred times and you have a full CAD assembly. There we go.
Here's this one's better.
Much better. So, does everyone have Fusion 360 who's here?
I'm downloading it right now.
All right. So for those of you who have it, let's try making a very basic shape just to get a feel for how Fusion 360 controls. So if you want to open up Fusion 360 and share that screen. There we go. Let's see. Where's that? Where's that? There we go. So, when you open Fusion 360, this is what you'll see. Close enough. Let's say we wanted to make that rolling pin we just talked about. We're going to start by making a sketch by hitting the Create Sketch button and then choosing some plane to sketch on. Right now there's nothing in here, so we can just choose one of the 3 origin planes. If we had another part in here, we could sketch off of that part to continuously build references. So if I just choose a plane at random, yes. Oh, forgot about that. I don't want to see a recording of my screen, do they? So now that we're in the sketch plane, we can use sketch tools. The sketch not only defines our geometry, but it's also where parametric CAD gets its name. We can use parameters to define the dimensions of our part. So if I were to make a circle, let's say that I think I want a pretty small rolling pin at first, maybe 2 inches across. Just type in 2, it's all set. Then if I'm going along, I'm doing some testing, I find out maybe 2 inches isn't big enough. I can go in and modify the parameters of the dimensions to change that part. This applies to any dimension that you put on any part in the sketch, and it also applies to the 3-dimensional extrusion you do of a part. You can always go back and edit your sketches later on, and it'll pull that change through the history for you. So if I had already modeled everything and then changed that from 2 to 6, it would just expand to get bigger in the final design. Let's go over some of the controls for the cameras, and then we're going to do a basic exercise to try and design a part. So for starts, just working from left to right in Fusion, over here you have your browser. The browser is where all of your sketches and parts in this file will be. You can use this to help organize a very large or complex part into sizable chunks that you can select, you can hide, you can make them selectable, unselectable, make them transparent if you want to work on a part behind them, etc. Up along the top, you have your toolbox. In Fusion, 99.5% of the time, you're going to be using just the solids toolbox. Surface, form, mesh, sheet metal, those are all more for very specialized design concepts that we don't touch on too much. Within the toolbox, you're going to find a couple of different categories. So create would be where you can begin creating shapes. So you have nothing at all, this is where you would create a sketch, turn that sketch into a 3D body. And if you needed just a very basic common shape, there's shape generators for that. Once you have a shape, the modify tools let you manipulate it. So this would be maybe you wanted to make it a bit longer, maybe you wanted to cut it in half, maybe you wanted to round over the corners so it's not a sharp piece. This is also where the move tool is, which is a very important tool. Now, for some of you who are just opening Fusion for the first time, your toolbar may not look like this. Some of the tools you'll have to go and click on the drop-down menu and get, but that's inconvenient if you're going to be using a tool a lot. So the tool that you find yourself using time and time again, you just click the 3 dots to bring it up to the toolbar, and then it'll just live up here as a button you can easily access at any time. Beyond modify, we then have assemble. We're not going to touch much on assemblies today, but just as a quick overview, this is how you would join together multiple components in space. So if we have our entire assembly of the rocket, this would be how we define how the threaded rod connects to a bulkhead, connects to the body tube, connects to the fins, etc. Construct creates things that are not really part of your model, but help make modeling easier. So let's say maybe you want to make a sketch halfway between 2 edges of a part, or you want to make a sketch that's at a 15-degree angle to some part you already have. Using this menu, you can create new planes and new edges that you can then use to make sketches on. Beyond that, inspect. The only critical thing here in inspect that you really need to know about is the measure tool. Pretty self-explanatory. Just click on 2 points and it tells you the distance between them. And the last one that I want to cover up here is the insert button. If you ever need to model something that is a little bit complex and there is no CAD model available for it, you can insert an image of it and then sort of trace the image to get your final part in CAD. We do this a lot to get nose cones from OpenRocket into Fusion 360. Any questions so far about the interface or any of the buttons that you see on screen? All right. One more thing to go over before we start designing a part is how to move your camera. So most of you are probably on a touchpad right now on your laptops. So it's not very easy to move your camera. Luckily, this little cube up here in the top corner, this is your view cube. You can click on any face to change how you're looking at a part. So if I just quickly create a cube here so you can get an idea for how we are doing this.
Fusion train without a mouse, Jim.
Yeah. See, by just clicking on one edge of the cube up here, it'll change our view of the part. This is also useful because this will mark what your Z, Y, and X axes are in your design, which is critical for when you go on to manufacture your parts.
When I was messing around with Fusion before, something that annoyed me that was different from AutoCAD was like snap points.
Yes.
That was very different and was difficult to learn how to try and maneuver objects so they snap to where I wanted them to.
Yeah, the snapping in Fusion, it will be based on how far zoomed in you are to your part, which can be a bit weird at times if you're just on the precipice between 2 different levels of snapping.
Okay.
So if you ever find that parts are sort of not sticking where you want them to be, you can hold down, I believe it's the Shift key, and it will turn off snapping altogether. Or I think it's the control key, will set a fixed snap size.
Okay.
You can also modify a lot of those settings with this small settings menu down at the bottom. So your grids and snaps, you can change your snap grid and grid settings. All right. So now that we have a basic overview of how Fusion works, let's go ahead and make a part. I'm thinking something pretty simple. How about a die, a singular of dice? So who has an idea of how we would start to make something like this?
Cube.
We could start with a cube, yep. We could do create, and then box, cube, same thing, and pull that out to the shape we want. We could also create a sketch, draw a square, and then extrude it out to the third distance.
Yeah.
So whichever one works best for you. For a shape like this, it's simple enough that we could just do it with a box.
Does it create like a hollow box or a solid cube?
Creates a solid cube. I think it just calls it box in case there's like, it's not like a same dimensions on all three sides.
Yeah.
So let's make a die that is,
Also, how do you change from metric to?
it's a good question. So if you ever want to use both, if you're ever typing in a dimension, you could put in like 4.7 inches or 3.7 millimeters, and it will do the conversion on the fly. To update the default for the file as a whole, you go to Document Settings in the browser, select where it says Units, and then choose your new units from the dropdown.
If somebody asks a question, they should repeat it.
That's a good idea. All right, so let's make a die that is about 4 inches on all sides. So I can sort of drag the box out into space, type 4 in for the first dimension, hit tab, and then 4 for the second one. And then I can type in 4 for the thickness to get my cube. Now in your sketch, if you accidentally typed in 3 or you didn't type in any set number, you can just double click on the dimension to modify its value. So if I do that again, or you could also, in the box tool, use the box length and width settings. Like that. Now you notice at the bottom, it says operation. Most of the tools that you're going to use will have an operation selector, and the two most common you're going to use are new body, join, and maybe sometimes cut, depending on what you're doing. New body, as the name implies, makes a new body. If I were to use the join tool, it would take the two bodies and sort of weld them together. And if I was to use the cut tool, it would subtract the one body from the other. So if I wanted to make this a hollow cube with maybe an opening on one side, I can draw another box here and select cut. And you can see it's going to cut away the inside. Or if I wanted a cube with a part sticking out the side, I can do that. And then set the operation to join. For now, let's just stick with the single cube. Did everyone get a cube?
How do I move the screen?
You can move the screen by selecting the pan tool at the bottom. And then when you're done with it, just press escape. If you have a mouse, it's middle mouse click and drag.
If you've lost your part, how do you get back to it?
If you've lost your part, you can click the home button up here, and it will bring you back to a default view of your part. So if you ever zoom way too far in, way too far out, you get lost out in who knows where, it'll bring you right back.
Hey Jim, how do I change my default home view?
If you want to change your default home view, just go to some new view that you want to set, right-click on the home, and then set current view as home. For the views, I don't believe so. No. For the views on the view box, there are no keyboard shortcuts. Normally, you'd be using a mouse instead of using that, though. To see if anything has a keyboard shortcut, you can just hover over it and it will tell you. So like press pull has a shortcut of O, fillet has a F, move copy is M, delete is the delete key, etc. Yeah.
What is form? Like create form? So click on that.
Gotcha. So the question was, what was the create form?
Yeah.
In Fusion, we're using right now the traditional parametric, draw lines, extrude things, toolbox. Form is used when you are modeling maybe a natural or ergonomic part, like a computer mouse, the handle for a tool, etc. In form, you start with a blob, and then you can press and pull on points of that blob to curve it into the final shape you want. So it might not necessarily be dimensionally accurate, but you get a better surface curvature to it than you can define just by drawing lines. If you want to get out of the form menu, you just delete the form on your browser and then select solid up at the top. What's that?
Form isn't an option, right?
Form is not an option.
It's not on top of here.
Interesting. Are you using the educational license?
I got no idea.
That might be why. So as students, you get access to pretty much all the tools in Fusion 360 through your educational license. If you signed up using a personal Autodesk account, you only have your personal license for Fusion, which severely limits what you can work on. You'll really see this if you go into manufacturing. The student license can do a ton more in CAM than the free version can.
Yeah, I have the educational one. It's under the, like above create, there's like a purple cube that says create form.
Ah.
And then it'll take you into.
Oh yeah, I see it now.
Right, so you probably just have, did I hide it on
No,
mine?
you have a different tab that says form.
Interesting.
Mesh.
So if you have a create form tool up in create, you can hide it if you want by just selecting it and dragging it out. Or leave it there if you ever want to use it again. What did I just take off of there? Was that extrude?
Time to do that.
There we go. Move that back. Perfect. So any more questions about designing the cube? We all got that? Awesome. Now right now this cube looks sort of boring, just gray. By default, every part you make in Fusion will be out of steel. It just has this very boring gray look to it. For making simple parts, that's okay, but if you're making something very complex, maybe you want to know where the center of mass of it is, you can modify the physical material. Yes?
Blue.
Blue?
Yeah.
Do you have it highlighted right now?
How do I tell?
Just click and drag somewhere out in space.
No, it's not highlighted.
Very strange.
Material?
Well, let's see if maybe you have a different default material then. So if you go into Modify, Physical Material, this is the Physical Materials Settings menu. Like I said, this is very important for if you're trying to do any center of mass calculations for your model, or if you're going to be doing any renders and animations of your part. If everything is just steel, it looks very bad because it'll just be a very dull gray all the way through. And it also makes it hard to differentiate between parts in a multi-part assembly. So let's change our die to be, white plastic. That works. So you can go under plastic, and then you can see a preview of what each of the physical materials are going to look like on the side. Now, if you look closely, you'll notice some of these previews are like a donut shape, and some of them are a solid sphere, like the clear acrylic. The difference there is that anything that has a donut shape is a solid surface. So if I were to change this to be acrylic, it'll just be that gray color. But if I was to change it to acrylic clear, I'd be able to see through the part and see the components behind it. To change the physical material of a part, let's say I want to do this one as ABS plastic. You can click on it and drag it to the body, Or if you want to modify a lot at once, you can click it and drag it to where the other material is in your palette. So say I had 20 parts made out of steel and another 30 made out of aluminum, and I wanted to change all the steel parts to aluminum, I could just drop the aluminum right on top of the steel and it'll change it all for me. It looks a little bit better. Now, what if you wanted to do something that was not critical for the part, but you just wanted it to look nice? Maybe you wanted something that looks like water, or you wanted a very glossy paint or powder coat, or maybe even like a wood finish. Under the Modify tab, there was also the Appearance menu. So while your physical material defines your center of mass and your default look of your part, appearances will override the look of physical material, but not the physical properties. So if I was to change this cube to look like paper, it didn't change much, did it? Let's find something a little bit weirder. Here we go, carbon fiber. So now the cube has the look of carbon fiber, but it's still going to have the same mass and strength that it did of the plastic part.
Sorry. How do you make it?
I just chose carbon fiber and then dragged it over. So go ahead and choose some appearance that you like for your die. It can be whatever you want. Some of them, like the woods here, you see how instead of a donut shape, it's a cube? The cube means that it has some special grain texture to it. So if I was to put like the walnut on here, you can actually see the part has a grain. And when you go and render that, you can't see that at all, can you? How about, you can barely see it there. So if I was to go and make a render of this part, it would actually cut the grain pattern to make it look like a raw piece of wood. So I'm going to do paint.
Make it, carbon.
What's that?
Make it carbon.
I just chose carbon fiber under the carbon fiber menu and then dragged it over. You might not have carbon fiber as a default. Fusion only downloads a certain number of the model
It's under miscellaneous.
miscellaneous. There you go. You can also make your own appearances. Maybe you wanted like red carbon fiber. You can modify an appearance under the My Appearances menu. But that's a bit advanced for today. Let's just stick to the defaults.
Don't we need to fill in the edges? Because the dice actually have rounded corners.
Yep, we're going to get to that as well. Don't worry. So I'm going to make mine powder coated blue. Or I won't actually, because I can't do powder coated blue.
You
So,
need to download them.
yep, I can't download because I'm running an outdated version. So I'll keep it as carbon fiber. So obviously, like it was said, this doesn't look much like a die yet. So what do we still need to do? Need to
Numbers.
need to put numbers on it. Need to clean up the edges. So let's put our numbers on first. To do this, we're just going to make a small detent on the top of the part. Now, since we have 6 faces, let's do this a few different ways to show off how we could do this. So the first way we're going to do this is click Create Sketch and click on one of the surfaces of your cube. Your view will auto-adjust, so you're looking head-on at the cube now. Let's make this the 1 spot.
Well, I can do that.
It didn't automatically adjust your view?
No.
Is there a sketch on that surface, though? Like, can you see the sketch plane?
This is what
Yeah, seems to have auto orient turned off for some reason.
You should change material. This is hard to see.
Ah, got it. So if we're going to make the 1, obviously you need to have it centered, right? You can't just put the hole wherever you want. There we go. That should be easier to see. So how are we going to find the exact center of our part? What we can do is grab the line tool and press X on your keyboard. This will turn on that little blue box on the side there. You can see it blinking on and off, labeled construction. So a construction line, if I were to draw one out here in space, we zoom in. See how it's a dashed line instead of a solid line? That means that if I was to draw a shape out of this, it wouldn't do anything. But if I were to draw a shape out of real lines, it would treat it as a part that I can extrude. Construction lines are useful for aligning your parts and aligning your sketches, and then changing back to real ones to make the actual geometry you want. You press the X key or press construction on your menu on the right. What's that? I just knew it was the X key. I just realized it doesn't actually tell you when you mouse over.
I will say,
Why is that?
on Autodesk website, there is a list of Fusion 360 shortcuts. I can link it in general. In general.
So let's find the center of our cube here. Now we could do this by drawing a line from corner to corner, corner to corner, and where the two meet up, that'd be our center. Or if I choose the line tool and I sort of move my mouse along the top here, see how it suddenly snaps to a point with a triangle? That means that I'm at the midpoint of that line. So I can click there to start a sketch. And so now I'm equidistant from either side of that edge. You can also see the little crosshair that showed up on the other edges of the cube. Since Fusion assumes that we're trying to find the center of something, it will automatically pop those up. So what I can do is just sort of move my mouse over it. And you see how I now have a second dotted line at the bottom? I can then move it until we are perpendicular and click. And now I know that that point is in the exact center of our face. So let's just wait a second for everyone to catch up and get that.
Now, seeing as our cube is 4x4x4, can we just find 2x2x2?
You can do that as well, yep. There's a lot of different ways that you can do this. One of the benefits of doing it this way, though, is if I were to modify the size of this cube, it will keep that line at the midpoint, no matter how big or small the cube is.
Can you turn on auto
So the question was, how do you turn on auto orient? I believe you click the look at button underneath construction. You could also just select which side of the view cube you want to be looking at that the sketch is in line with. And you can rotate it by just using the two rotates here. Do we have a chat?
No, that was me.
Ah. So does everyone have this center point? Is it giving you a specific issue or?
Well, I'm trying drawing it and then I do it like all the way on the opposite side of the cube.
You might be just looking at the wrong face of the cube. Let me just see, make sure everyone's got this. Well, you have to choose, you have to go to sketch. Choose the line tool. And then
I have a question about this split figure out. That space trace needs to
go to triangle.
James would be the person to ask.
And then sort of put your mouse over the edge of that one, so you see a triangle. And then drag it back over. And there you go. And then hit escape to and click over here to there you go. All All right. Does everyone have that? Awesome. So now let's go over one of the ways that we could make our mark at the top here. So if you ever look at a real die, it's going to have like a semicircle cut into it. So to make a semicircle, we can create a sphere at this point and then combine the two bodies with the sphere cutting the cube. So to do this, let's go, instead of the sketch menu, to solid, create sphere. Then we can click on the dot that we just made, and it will make a sphere around that center point. And if you zoom in close, you can see that it's going to be cutting away a good amount of that material. So let's set that to be like 0.25. Oh, didn't like that. 5 inches? Nah, maybe 0.5 inches. There we go. And once you have that to a shape you want, just click OK. So now if we look at our part at an angle, you can see we have a semicircle cut into the face. Any questions about how we did that? Anyone get stuck? All right. Let's now do another side of the die with the two dots, but let's do it in a different way. So let's just choose another face, create the sketch.
How would you cut the material?
So when you create the sphere at the bottom, there will be an operation selection, and you choose cut from there. If you created the sphere as a body instead, you can use the combine tool under modify. Select the two bodies and then use cut as the operation. If you had selected new body instead of cut when you made the sphere, you would have to go in and manually combine the two. What's that? Yep, that's how you should do it. All right, so now let's make this side of the die as if all we had was a drill press. So we're just going to drill a hole straight in and out. Just whatever side you want. I believe there is a proper standard for which way the numbers should be in relation to each other on a die, but that's not important for what we're doing. Now, a 2, can you pull a picture of a die, actually? I just want to make sure I'm doing this right. What does the 2 side of a die look like? Is it diagonals?
It's like 4, but you just.
Yes. Okay. So let's do this using the mirror tool, since we want the two dots to be equidistant from the edges. To start with, we're going to need a line right through the middle of our part. Since we're going to have a dot in the top corner and a dot in the bottom corner, let's draw our construction line from diagonal to diagonal. Are you in a sketch? So you have to get the sketch menu, you have to be in a sketch. You create sketch on a face, and they should pop up automatically. Awesome. So to make a symmetrical part, or to use the mirror tool, we start by defining some line that we're going to mirror across. And then let's draw our geometry. Just like before, we're going to want to make a dot at some location, which we'll then use to set up where our drill will be. So I'm going to just do a construction line from this corner and bring it in. That looks good. Let's just wait for everyone to get that. All right, and then to make this into a actual hole.
How far did you bring that in?
however far you want.
I put it in 1.4 inches.
All right. What's that?
Is there a point tool?
So the question was, is there a point tool? There is a way to make a point just on a line anywhere you want. Ideally, though, you'd always want to use a point that's at the end of some line so that it's geometrically defined. Because just putting a point on the line, it can slide wherever it wants along the length of that line. So since this is the end point of the line, I can't move it. It's stuck there.
Alternatively, you can dimension the point on a line.
Is there a way to say, like, I want a point, or I want this line to be 3/4 of the distance from the corner to the
3/4 of the from.
You would have to make 2 half intersections.
Yeah.
So what I did was I took a point from the corner to the center of the line, and then just took that automatically set value and divided it by 4 and multiplied by 3.
That would work. If you already had a sketch line that went all the way and you wanted to get a third of that sketch line, you can set up the dimension to be dimension 2 divided by 3 or something like that. Although in general, it's best to avoid those, since if you were to go back and tweak that one, it might cause other things to suddenly change when you're not expecting it. So now everyone should hopefully have a point somewhere out in the corner there. So we're going to click the C button on our keyboard or select the circle tool from the top. And we're going to make a circle here. Now, if you notice when you open the circle menu, over here, there's the feature options. By default, when you choose the circle tool, it'll ask you to define a center point and a diameter. But maybe you want to make a circle that's defined by 3 points or 2 points and a distance. You can change the selection mode by clicking on one of the feature options. Hovering over will give you more information about what it's going to do. So if I was to do a 2-point circle instead of center diameter, it would ask me to select 1 point, and the diameter of the circle would be based on wherever I put that second point. For this, we're just going to use the center diameter, though. And let's make that 0.5. Oh, perfect. Yep, so you're going to do center diameter, call it a 1/2 inch or so. Now, when you make your circle, do you notice how it's blue instead of black like other lines we made in the past? That means that this circle is underdefined. So if I were to go and click and drag on the circle, I can just move it however I want. Because the only constraint that it has right now is that the line it's on is perpendicular to that line. So we need to tell it that that circle can't move. The easiest way to do that would be to use a fix constraint at the top. We can just choose 2 things and tell them that those 2 cannot move relative to each other. You could also do something like a, maybe you had a circle inside of a circle. You can constrain one circle to the other circle using a coincident constraint. By default, Fusion 360 will generate most of the constraints you need, so it's very rare that you have to go in and add them automatically. Now that we have that circle constrained, let's create our second one. Like we said, we could go in and just draw a line, draw another circle, and do it that way, but we're going to use the mirror tool. Yes? That's a good question. So the question was, should we cut first? At this point, the order of operations doesn't matter too much. What we could do is cut the hole, then copy the hole over the mirror line, or create a body, copy that over the mirror line, and combine them all, or copy the sketch and extrude both at the same time. It really comes down to what exactly you're working on. So for this one, I would do it in the sketch plane, because if we're to make that a cut through, we would then need a plane to mirror them across, whereas right now we just need a line since it's a sketch. So if you were to do it by making the hole, you would then need to define a plane from like the construct menu and use that as your center point for the mirror. So to mirror the sketch, we're going to go to Create, Mirror. And you can see first it's going to ask us for the object we want to mirror. We want to mirror just that circle, and the mirror line is that one. Once that's done, we can click OK, and now we have our two circles. Did you select a mirror line and an object?
How do we select that?
All right. And then once you have those two circles, we're going to go to Solid, Extrude, and we're going to extrude them down some distance.
Where do we go?
Under Solid, Extrude at the top. And then we can select the two circles, and we can say that we want them to go in.
How do we select the circle?
You just move your mouse over the circle, and it'll light up blue.
When it does, it selects the entire square.
So it might be that your sketch is hidden then. So if you go to Solid, Extrude, are you saying that it's doing like that instead?
Yeah.
So what you want to do then is over here on your browser, next to where it says Sketches, see if there's an eyeball or not.
Yeah, there is that one.
So, and you can see your sketch on the top of your part. So can you see the two circles on the top of your part like this, or does it look like this?
Yeah, I can see it the first way.
Okay, so then what you're going to want to do is when you go in to do your extrude, make sure you zoom in and select it. If you still can't highlight it, it's possible that your circles are construction lines instead of real lines.
When do we make them?
When we stop making the reference lines, it's okay. What you could do is just select the circles, close out of this, select the circle, and click the X key to change it from normal to construction and vice versa. So if it's construction, it would look like that, the dotted line. We want it to look like that, a solid line.
All right, now I can.
All right, so now you should be able to extrude those down. So we're going to select the two and then give it a distance. I put a 1/2 inch. So what do you guys think so far? Not too bad?
Now, when we extrude them, are they semi-spheres?
No, these will just be a cylinder straight down. So this would be more representative of if we were to take an end mill and machine out the part.
So what if we wanted to make those semi-spheres?
You would just use the sphere like we did on the previous ones. So the last thing we're going to go over before we break out into our first practice exercise is modifying things. So this die in its current state looks like it'd be a bit painful to use. It has really sharp edges on it. So let's smooth those over. When we're working in CAD, there's two ways that we can break an edge, so to speak. The first way is with a fillet. So if you go under Modify, Fillet, you can then select a couple of edges and drag the arrow, and it will curve them over with some set radius. If you wanted to add more, it takes them out of this fillet selection. You can hold the Control key and then click on edges. This will also work for the edges of a hole or something similar. And Fusion will just do its best to try and resolve all of those curves. So let's put like a point, I don't know, 0.12. That looks good.
I did have a minor difficulty. How did you get that?
the Fillet tool. It's under Modify, Fillet. So that looks good. This would be fine for 3D printing, but if we're going to machine it, maybe we want it to just be cut at an angle rather than being a rolled over ball. For that, we're going to use the Chamfer tool. So it's the same idea. You'd go to Modify, but this time select Chamfer. And it works the same way, where you just give it a distance and it will cut it at an angle. So what do you guys think? Good? Cool. So how about we do a bit of a challenge then? Can you guys all split off into groups of like 3, 4 people? Make sure at least one of you have a computer with Fusion in your group. For those of you online, you're just going to have to follow along best you can. Sorry about that. And let's make a drawing on the whiteboard.
What meetings are
Good one. Find out, I guess. All right, so here's your guys' challenge. How many of you built your L1? Some of you.
There's
Who built your
more-
L1?
Who built your L1 yet? Is there at least one person in each group?
Yeah, everybody's.
Okay. So your task is to make a tool to help align the fins as we put them onto the L1. Did someone in your group build an L1 who can sort of describe the process? That's what I'm going to tell you right now.
Okay.
So the rocket will have a radius of 4 inches, or sorry, a diameter of 4 inches. The fin will have a thickness of a 1/4 inch. And you need to find a way to make a part that will fit cleanly onto the curve of the body and hold the fin straight up and down. So assume that you're holding at least 1 inch of the fin. So go ahead and brainstorm in your team for a few minutes how you think you would start to design that. Feel free to bust out a piece of paper, try and do some sketching. What's up?
What's the distance each thing sticks out from the rocket?
Make it so your tool can hold at least 1 inch of the fin.
Like outward?
Yeah. And if the rocket is sitting straight up and down, the fin is 5 inches tall. Does that make sense? So take a few minutes, see if you can figure out a way that you would design this. Nope. So you got to be a bit creative with how you design this. Anything in the chat? For those of you on Zoom, can you see that okay?